All right, question 1. Based on the pattern, what's the next term of the sequence? So I have a sequence of numbers here. Okay, and a sequence just means a list, and we're going to say there is a pattern to it. Now the whole trick for this problem is figuring out what the pattern is. Now that's going to take a little bit of guess and check work, a little bit of thinking, but the pattern we have here is to get from 3 to 7. What I can do is I can multiply by 2 and then add 1. Okay, 3 times 2 is 6, plus 1 is 7. And I can check and make sure that pattern works as I continue. 7 times 2 is 14, plus 1 would be 15. 15 times 2 would be 30, plus 1 is 31. 31 times 2 is 62, plus 1 would be 63. So if I keep that going, that times 2 plus 1 pattern what I end up with then is 63 times 2 would be 126, plus 1 would be 127. All right, for my answer for this one. Question 2, what is the 47th term of the sequence? Now my sequence is ABCD, ABCD, dot, 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 so I'll continue ABCD, ABCD, ABCD. Now what I don't want to do for this one is actually count through 47 times. What I can do instead is recognize that the length of this sequence is 4, okay, meaning that every fourth term is going to repeat. In other words, every fourth term is going to be a D. So what I can do then is I can figure out a number that's not necessarily the 47th term, but something that's close to it that's divisible by 4. So for example, I know that the 44th term is divisible by 4, therefore it's a D. And what I can do is count up then. The 45th will be the starting the pattern over in A. The 46th will be a B, and the 47th will be a C. Okay, so I know C is my 47th term. Okay, what I could have also done is gone with the 48th term, which would be a D. So I know 48 is divisible by 4 as well, and then counted backwards 1. Either way, I get that C is the 47th term. All right, question 3 asks, how far off is a storm with 15 seconds between seeing lightning and hearing thunder? Okay, so what I have here is a graph that shows the seconds between seeing the lightning and hearing the thunder, okay, going from 0 to 40. And then the y-axis gives me the distance that that storm is away based on that information. Okay, so for example, if I count 10 seconds between seeing the lightning and hearing the thunder, okay, that storm is 2 miles away. Now the pattern part comes into it is it looks like this pattern makes a pretty nice straight line for me. So if I want to know how far off is a storm with 15 seconds between seeing the lightning and hearing the thunder, I'll just go to 15 on my x-axis. I'll count up to where I hit the line. Okay, come over here, and that looks like it's going to be a 3. Therefore, that storm would be 3 miles away. All right, question 4 asks, which statement is a counterexample for the conditional? Okay, conditional statement, if-then statement. If you go to college in Minneapolis, then you go to the University of Minnesota. U of M is in Minneapolis. And I've got the options actually pulled up here because there's a lot of different counterexamples for this one. We got to pick the right one. Okay, we could say Tim goes to Augsburg College in Minneapolis. That's a good counterexample because that is a college in Minneapolis, satisfies the hypothesis, but it doesn't satisfy the conclusion. He's not going to the U of M, he's going to Augsburg. Okay, the reason these other ones don't work real quick is Thomas goes to the U of M in St. Paul. That's not Minneapolis, so that doesn't satisfy my hypothesis. Joe goes to St. Cloud State. Okay, again, that doesn't satisfy the hypothesis. That's not going to college in Minneapolis. Same thing with Jenny doesn't go to college. It doesn't satisfy the hypothesis. The reason that this one works is it satisfies the hypothesis, college in Minneapolis, but it doesn't match up with the conclusion.